to Educator.com. Today we're going to start talking about quadratic equations and inequalities, and the first thing we're going to review is graphing quadratic functions. Recall from Algebra 1 that a quadratic function has the form f of x equals ax squared plus bx plus c. So that is the quadratic function in standard form, where a does not equal 0. And if a were to equal 0, this section would drop out, and this is actually what makes it a quadratic function, the x squared. Otherwise, you would just end up with a linear function, which we have described earlier on in the course. So let's first talk about an example of a quadratic function. It could be something such as f of x equals x squared plus 4x minus 3, or f of x equals negative x squared plus 1. And here, in this second example, b is actually equal to 0, and that is allowed, so this drops out, but as I just discussed, a cannot equal 0. We're going to be working with the graphs of these functions today, and first just talking about the general shape of these curves. The curve of a graph of a quadratic function is a shape called a parabola, and they may open upward. So a parabola can open upward. It could open downward. And you'll see varying shapes such as wider parabolas or narrower parabolas. And as we get deeper into discussing this topic, you'll be able to tell just from looking at the quadratic function roughly what the shape is going to be and which direction it's going to curve in. So getting started with some properties of parabolas. A parabola has an axis of symmetry, and that axis is described by the equation x equals negative b over 2a. And what the axis of symmetry is a vertical line that divides the parabola into two halves, two symmetric halves. And the parabola intersects this axis of symmetry at what's called the vertex. Recall that the x-coordinate of the vertex is given by x equals negative b over 2a. So to illustrate this with an example, if I were looking at the function f of x equals negative x squared minus 2x plus 1, then first let's look for the axis of symmetry. And the axis of symmetry is up at negative b over 2a. Well, here a is equal to negative 1, because recall that standard form is ax squared plus bx plus c. So a is negative 1, b is negative 2, and c is 1. So if I want negative b over 2a, that's going to give me negative 2 over 2 times negative 1. So looking at that, that'll be a negative and a negative to give me a positive over negative 2, which equals negative 1. Therefore, the axis of symmetry is going to be a vertical line right here at negative 1. So this is the axis of symmetry. Now, this point where x equals negative 1 is the x-coordinate of the vertex. However, I need to find the y-coordinate. So in order to do that, I'm going to go back and look for f of negative 1. So replacing my x terms with negative 1, that's going to give me negative 1 squared is 1, so that's negative 1. And then that gives me negative 2 times negative 1 will become a positive. So that's plus 2 plus 1. So this is 3 minus 1, so that equals 2. So what I did is I found the x-coordinate for the vertex, substituted that in for my x value, and found that f of negative 1 equals 2. So the y value for the vertex is going to be 2. So the vertex is going to be at the point negative 1, 2. So that's negative 1, 2 right here. Okay. Now, to further graph this, let's go ahead and find some points. And it's best to pick some points around the vertex, because if I pick points way out here, my graph's not going to be as accurate. I want to get a general shape of the curve in the area of the vertex. Okay, so my vertex is right here. Okay, so pick some x values, and then let's go ahead and determine what the y values are based on that. When x is negative 2, you can go ahead and work this out for yourselves, but when x is negative 2, if you work the whole thing out, you would find that y is 1. Okay? When x is 0, you can see that these two are going to drop out, and y is going to be 1. When x is 1, that's going to give me negative 1, and this is going to give me positive 2. So it's going to be, excuse me, this is going to give me, when x is 1, this is going to give me negative 1, minus 2, plus 1. That's going to come out to negative 2. So one more point maybe. When x is 2, working this out, this is going to give me 2 squared, that's negative 4. And then 2 times 2 with a negative is also negative 4. Plus 1, that's going to equal negative 7. So here we get negative 7. So go ahead and plot out the rest of these points. When x is negative 2, y is 1. When x is 0, y is 1. When x is 1, y is negative 2. And then this one's way down here, so we'll leave that off. But looking at how the axis of symmetry can help you with graphing, here I've got one point on the left, and I have a couple points on the right. Because I know that the axis of symmetry divides this into two symmetric halves, I can actually add another point right over here. So because this is symmetrical, I have a point here on one side of the vertex. I have another one here. Looking at the axis of symmetry, if I have a point right here, which is an x value that's 1, 2 away from the vertex. So on this side, 1, 2 away from the vertex at negative 3. And then the y is 1, 2, 3, 4 down. So here I'd have it, again, compared to the vertex, 1, 2, 3, 4 down. So that's going to reflect it right across here. So using the axis of symmetry, I can find the point, the mirror image point. So even if I've just graphed this half, if I have the axis of symmetry, I can reflect across to the other half. So just reviewing. An axis of symmetry for a parabola is given by the equation right here, and I found my axis of symmetry, and that is a vertical line. The parabola actually intersects that axis at the vertex. The x value of the vertex is also given by this equation. And once I've found that, which was negative 1, I can substitute that in and find the function's value for y at that point, which turned out to be 2. The axis of symmetry can help you with graphing. Okay, now we talked a little bit about the vertex, but the vertex can give you either a maximum or minimum value of the function depending on the shape of the curve, whether it opens upward or downward. That tells you if you have a maximum value or a minimum value. So investigating this a little bit further. If the coefficient of the x squared term is positive, the graph will open upward. Okay? Whereas if the coefficient of the x squared term is negative, the graph opens downward. So recall that the standard form is x squared plus bx plus c. So that's the standard form of the function, f of x. And if I look at a, if a is greater than 0, so that means that the x squared term is positive, the parabola opens upward. If this is a negative value, if a is less than 0, the parabola is going to open downward. So just by looking at the equation I'm given, I'll have a general sense of the shape, whether it opens upward or downward. Now, if this is positive and it opens upward, let's give an example. If I have a parabola like this, it opens upward, this tells me that a is greater than 0. The vertex is going to be a minimum. And thinking about what that means the minimum value that y can have, the minimum value of the function. So if the coefficient of x squared is positive, the graph opens upward and the function has a minimum value. Right here at the vertex, that is as small of a value as you will find for y. Y only gets bigger from there, no matter what x value you put in. Conversely, if I have a parabola that opens downward, okay? So here, a is less than 0. I have a parabola that opens downward. In this case, the vertex is going to give me a maximum value. So right here, y is approximately equal to 1. That's as large as y is going to get. No matter what value I plug in for x, y is just going to be smaller than that. So again, this gives us more information about the graph just by looking at what this coefficient is right here, the coefficient of x squared. So in order to graph, as I said, once you find the vertex, so you find the vertex, you look at the equation and say, okay, it's going to open upward or downward, and then look for some points around the vertex to get the shape of the graph. You know, does it open very wide? Is it a very shallow graph, or is it a very steep graph? And we'll talk more about that later on, about the shape. But for now, just focusing on the vertex, whether the parabola opens upward or downward, and then finding some x and y values in order to help you make the graph. Okay, practicing these with some examples. Find the equation of the axis of symmetry, the coordinates of the vertex, and the graph of this function. Okay, first recalling that the axis of symmetry is given by the vertical line at x equals negative b over 2a. And then always just reviewing what standard form is. In order to find this, it's ax squared plus bx plus c. So here I have x equals, and then my a value is 1. There is no bx term. Therefore, b must be 0. Okay? There's no term with a coefficient and then just x. That implies that b is 0. And then here, c is negative 9, but I really don't need to worry about that right now. So I'm going to go ahead and substitute these in. And as soon as I see that b is 0, it honestly doesn't matter what a is, because if you take 0 and divide it by anything, you're going to get 0. Now, this is the equation for the axis of symmetry. It's a vertical line at x equals 0. So right here, the axis of symmetry is just going to follow this y-axis. The coordinates of the vertex. Well, I have my x coordinate right here is 0. That this axis of symmetry is going to intersect this parabola at x equals 0 and then at some y coordinate. In order to find the y coordinate, let's find f of 0. Okay, so f of 0 is negative 9. Okay, so let's make this negative 2, negative 4, negative 6, negative 8, negative 10. So this is the y-coordinate for the vertex, the x coordinate is x equals 0. So the coordinates of the vertex are 0, negative 9. So 0, negative 9 is right there. Now, let me go ahead and write that in. What that is the vertex right there. Now, in order to graph this, I need to find some other points. So let's find some values for x and then figure out what f of x is at those points. When x is 1, well, that would be 1 squared minus 9. You're going to get negative 8 for y. When x is 2, 2 squared is 4 minus 9. That's going to give me 5. Let's see. When x is 3, 3 squared is 9 minus 9 is 0. So let's try these points. And that's going to give me when x is 1, y is negative 8. When x is 2, y is going to be, actually this should be negative 5. Y is negative 5 right here. When x is 3, y is 0. So 3 is about here. Okay, now recall that the axis of symmetry can help me to graph. It can save me work because here I have some points on one side of the axis of symmetry, and that means that the other side I can just reflect across to get points that are mirror image. So approximately here, and then here at, this is about here, and then here is at 3, 0. So I'm going to go over here to negative 3, 0, and put a point. Therefore, I was able to cut down my work by knowing that the axis of symmetry divides this into two symmetrical halves. So checking, I did find the equation of the axis of symmetry, x equals 0. I found the coordinates of the vertex, and that was 0, negative 9. And I graphed by finding some points and then reflecting across using the axis of symmetry. Okay, again, find the equation of the axis of symmetry, the coordinates of the vertex, and graph. So the equation of the axis of symmetry is given by x equals negative b over 2a. And here I have a equals 1, b equals negative 4, because f of x in standard form is ax squared plus bx plus c. So I'm going to go ahead and find this. Axis of symmetry is x equals negative b, so that's negative 4, over 2 times a, which is 1. Therefore, x equals, that's negative and a negative gives me a positive 4 over 2, which equals 2. So this is the axis of symmetry. Go ahead and form an xy axis. Okay. So the axis of symmetry is going to be right here at x equals 2, and there's going to be a vertical line passing through that point. My next thing that I need to do is find the coordinates of the vertex. And I have the x coordinate, that's x equals 2, but I need to find the y coordinate. And the y coordinate is going to be given where at f of 2, which equals 2 squared minus 4 times 2 plus 4. So that gives me 4 minus 8 plus 4. So that's 4 plus 4 is 8, minus 8 is 0. So this equals 0. So the y coordinate at f of 2 for the vertex is 0. So the vertex is at 2, 0. That is where the axis of symmetry is going to intersect with the graph. Then to finish graphing this, I just need to find some points, some x values, and some y values corresponding y values. Okay, so let's start out with some points around the vertex. So when x is 1, that's going to give me 1 times 1, or 1 squared is 1, minus 4, plus 4. So these two are going to cancel, and I'm just going to get 1 right here. Okay, I already have 2. That's my vertex. How about 3? When you go ahead and plug this in and figure it out, you're going to get 3 times 3, that's 9, minus 3 times 4 is 12, plus 4, so that's 9 minus 12 is going to give me negative 3 plus 4, that's going to give me 1. Okay, when x is 4, if you work this out, you'll find that y is 4, and then another easy point, when x is 0, these drop out, and you get 4 here also. Okay, so when x is 1, y is 1. When x is 3, y is 1. When x is 4, y is 4. When x is 0, y is 4. Now, again, I could have used the axis of symmetry. I could have found even less points and then just used symmetry to find the points on the other side of that axis. Okay. So I completed the tasks that I was asked to do, which are to find the axis of symmetry, and that's right here at x equals 2. To find the vertex is here at 2, 0. And to graph this, which is a parabola opening upward with a minimum value, the vertex here is a minimum because this opens upward at 2, 0. Okay. In this next one, we're asked to determine whether the function has a maximum or a minimum, find the maximum or minimum, and state the domain and range. So we don't even have to graph this one, but we first need to look at it and determine if it has a maximum or a minimum. And the way we figure that out is by seeing what this coefficient of x squared is, what a is. Okay, here a equals negative 1. Recall that when a is less than 0, when a is negative, the parabola opens downward. Okay, now, just sketching this out to think about it, if the parabola opens down, it faces downward, the vertex is going to give me a minimum value. It's going to be, a maximum value, That's as large as y is going to get. Y only gets smaller. So here, the vertex is a minimum. Okay, vertex is a maximum value. Doesn't get any larger. If this were to open upward, then the vertex would be a minimum value. Okay, so here the parabola opens downward. My vertex is a maximum. Now, I'm asked to find that maximum or minimum. In other words, to find the vertex. And recall that the vertex is given by negative b over 2a. Okay. So I have that my a is negative 1. Here, b is 12. So let's find the vertex. It's going to be a vertical line at x equals negative b over 2 times negative 1. So that's going to give me x equals negative 12 over negative 2, or x equals 12 over 2, or x equals 6. So that gives me the equation. There's going to be a line at x equals 6. That's the axis of symmetry. So the axis of symmetry is at x equals 6. And that is a maximum value. So axis of symmetry, x equals 6. The next thing I'm asked to find is the domain and the range. Okay, well, looking at the domain, I could say that x is really any real number. I could say it's 1, 1,000, negative 200. So the domain is going to be all real numbers. it may be tempting to say, oh, the range is also all real numbers. But if you think about it, it's actually not. Now, let's go a little bit deeper and find this maximum point. Let's find the vertex. I found that x equals 6, so I know that my x-coordinate is 6. But let's find the y-coordinate, which is going to be at f of 6. So that f of 6 equals negative 6 squared plus 12 times 6 plus 8, which is going to equal negative 6 times negative 6 is 36. 12 times 6 is 72. So 6 times 6 is 36, and that's negative. So it's negative 36 plus 72 plus 8. Okay, so 6 squared, take a negative, plus 12 times 6 plus 8. So this is going to give me negative 36 plus 72 plus 8, which actually comes out to 44. So my vertex is actually going to be at the point 6, 44. And what that's telling me is this is the largest y is ever going to get. Now, y can be an infinite number of smaller values, but this is the maximum it's going to get. Therefore, the range is actually all real numbers where y is less than or equal to 44. So it might be tempting to just look at this and say all real numbers for y, but that in fact is not true because we have a maximum here that y cannot be greater than. Therefore, answering all of this, I determined that I have a vertex that is a maximum. I found what the maximum is, and it was 6, x is 6 and y is 44. So the maximum is actually y equals 44. And the domain and the range. The domain is all real numbers. The range is all real numbers such that y is less than or equal to 44. Okay. Example 4. Determine whether the function has a maximum or a minimum. Find the maximum or minimum and state the domain and range. Recall standard form. And that I need to look at the coefficient of x. I need to look at a, and here a equals 3. And since that is greater than 0, since a is positive, this tells me that this parabola opens upward. And since it opens upward, just to help visualize it, the vertex right here is going to be a minimum. It is going to be the smallest value that y can achieve for any x. They want me to find that minimum value. So I'm going to recall that the x-coordinate of the minimum value is defined by negative b over 2a. I know what a is. B is negative 12. So just figuring that out, that's negative times negative 12 over 2 times a, which is 3. That's going to give me a negative, and a negative is a positive 12 divided by 2 times 3, which is 6. So this is going to give me 12 divided by 6. That's 2. Okay, so the minimum, the coordinate for the minimum, the x-coordinate is 2. To figure out the y-coordinate, I'm going to figure out f of 2. Which is going to be 3 times 2 squared minus 12 times 2 plus 7. So this is going to give me 3 times 4 minus 12 times 2 is 24 plus 7. So this is 12 minus 24 plus 7. So that's going to give me negative 12 plus 7, which is negative 5. Okay. Therefore, the minimum value is going to be y equals negative 5. So this is my minimum. So now looking at this, in reality, actually, this is going to be at x is 2, y is negative 5. It's actually going to be more like this. We weren't asked to graph it, but just to help visualize it. Negative 5, let's say, is down here. This is actually going to be down here in this quadrant. Okay? Now, I found that I have a minimum. I found that the minimum occurs at y equals -5. What is the domain? Looking, I can make x anything I want, any real number. So the domain is going to be all real numbers. What is the range? Well, there's a limit on what that can be because I just said that the minimum value for x is -5. For y, the minimum value for y is -5 right here. That is the minimum value. Therefore, y can be greater, but it can never be less than that. So actually the range is all real numbers where y is greater than or equal to 5. The domain is all real numbers. The range is more restricted. It's all real numbers greater than or equal to -5. Okay, so we found that we had a minimum, and we know that because a is positive. We found that using the formula -b/2a to get the x coordinate, which is 2. Then we found f of x using 2, so f of 2, to tell me that y equals -5. Since y is -5, then there is a limit here on the range. The domain is all real numbers, whereas the range is only those real numbers greater than or equal to -5. That concludes this session of Educator.com, where we covered graphing quadratic functions. I'll see you next lesson.